I'm going to go through the answers to exercise 2 on page 18, just for question 6, where you are asked to predict if a molecule is polar or not. Okay, the first one I've got is H2S. For each of these, I'm going to go through the same kind of process, the same thought process to work out if it's polar or not. The first thing I'm going to ask myself is, do I have polar bonds in this molecule? I've got sulfur, hydrogen bonds. Sulfur is more electronegative than hydrogen, so I do have polar bonds. The next thing I need to ask myself is there symmetry within this molecule? To work out if there's symmetry, I need to know, are all the bonds the same? I've got 2 sulfur-hydrogen bonds. Both of those bonds are the same, so I'm going to write yes, the bonds are the same. Then I need to look at the shape. Is the shape a symmetrical shape? I've got 2 bond pairs and 2 lone pairs. That gives me a bent shape. Bent is not a symmetrical shape. Because you don't have a symmetrical shape, the dipoles will not cancel, and this will be a polar molecule overall. In the next example, I've got beryllium bonded to bromine. Do you have polar bonds? Yes, you do. Bromine is more electronegative than beryllium. Do you have symmetry? Are the bonds the same? Yes, you've got 2 beryllium-bromine bonds. Those bonds are exactly the same. Is the shape symmetrical? Around beryllium, you have got 2 bond pairs. There are no lone pairs, so your shape is linear. Linear is a symmetrical shape. Because it's a symmetrical shape, even though you've got polar bonds, the dipoles will cancel, and overall, it's going to be non-polar. Okay, so in this was not a symmetrical shape, but linear is a symmetrical shape. The next one, I've got ammonia. Do I have polar bonds? Yes, I do. Nitrogen's more electronegative than hydrogen. All of these bonds will be polar. Do you have the same bonds? Yes, you do. You've got 3 nitrogen-hydrogen bonds. All of those bonds are the same. Do you have a symmetrical shape? You've got 3 bond pairs and 1 lone pair. The shape is pyramidal. Is pyramidal a symmetrical shape? No, it is not. It is not a symmetrical shape. That means that the dipoles will not cancel each other out, and overall it is going to be polar. Okay, so your 2 not symmetrical shapes are bent and pyramidal. The others are all symmetrical. The next one I've got is BF3. Are my bonds polar? Yes, they are. Fluorine is more electronegative than boron. Are all my bonds the same? Yes, I've got 3 identical boron-fluorine bonds. Is the shape symmetrical? I've got 3 bond pairs. I've got no lone pairs. My shape is trigonal planar. Is trigonal planar a symmetrical shape? Yes, it is. That means that my dipoles will cancel, and overall, this is going to be non-polar. The next one, I've got SiCl4. Do I have polar bonds? Yes, chlorine is more electronegative than silicon. Do I have the same bonds? Yes, all 4 of those bonds are exactly the same. Do I have a symmetrical shape? Around silicon, I've got 1, 2, 3, 4 bond pairs. 4 bond pairs is tetrahedral. Tetrahedral is a symmetrical shape. It means all of my dipoles are going to cancel, and I end up with a non-polar molecule overall. Next example, CCl3H. Do I have polar bonds in there? Yes, I do. Symmetry, are all of my bonds exactly the same? No, they are not. I've got 3 carbon-chlorine bonds, but I've also got a carbon-hydrogen bonds. My bonds are not all the same, so I do not have symmetry. I don't even need to work out the shape. If I don't have symmetry, it is going to be a polar molecule. If you don't have symmetry, the dipoles are not all going to cancel each other out, okay? If you did work out the shape, you would see that it was tetrahedral. Tetrahedral is a symmetrical shape, but only if all of the bonds are the same, okay? If one of those bonds is different, you no longer have that symmetry, the dipoles will no longer cancel, and you will have a polar molecule overall. Next example, I've got a double bond in here. Doesn't change a thing. I just need to work out if I've got polar bonds, and yes, I do have polar bonds, that carbon-oxygen bond. Do I have symmetry? Are all my bonds exactly the same? No, my bonds are not all the same, okay? So as soon as I see I don't have symmetry because the bonds aren't the same, I can straight away just say that this molecule is polar. If you wanted to work out the shape, you would see you've got 3 bonding regions around carbon, so it would be trigonal planar. Trigonal planar is usually a symmetrical molecule, but in this case, not all of the bonds are the same, which means the dipoles don't all cancel out, which means it does end up being polar. Last one, do you have polar bonds? Yes, you do. Do you have symmetry? Are all the bonds exactly the same? Yes, they are. Do you have a symmetrical shape? Around sulfur, you've got 6 bond pairs. 6 bond pairs makes it octahedral. If it's octahedral, it is a symmetrical shape. Those dipoles will all cancel and you end up with a polar molecule overall. I'm now going to go through the answers to the exam questions that are just below exercise 2. I'm first going to go through this example on page 18. It asks you to name the shape of the molecule. They've drawn the dot and cross for you. You can see around SB that you've got 1, 2, 3 bond pairs and you've got 1 lone pair. You need to know that if you've got 3 bond pairs and 1 lone pair, that your shape is going to be pyramidal. Okay, you just need to learn your shapes. Pyramidal. So you can call it trigonal pyramidal or just pyramidal, and then you need to explain why. When you're explaining why, you need to state that there are 3 bond pairs and 1 lone pair around the central atom or around SB. And then you need to say electron pairs repel. I'm also going to add that lone pairs repel more than bond pairs. Those last 2 sentences can be learned off and used in all of these type of questions. Okay, electron pairs repel, lone pairs repel more than bond pairs, and you're going to pick up all of your marks. Then SbCl3 molecules are polar. They want you to explain why. There's actually quite a bit you need to write for just these 2 marks. Okay, the first thing you're going to say, you can't just say that SbCl bonds are polar. Okay, you need to see why they're polar. You don't need to know which element is more electronegative, chlorine or Sb. Okay, it is chlorine, but you don't need to know that. You just need to say that there is a difference in electronegativities between Sb and Cl. So SbCl bonds are polar. Okay, so the first criteria of a molecule being polar is that it has polar bonds. You need to explain why those bonds are polar. They're polar because there's a difference in electronegativities between Sb and Cl. The other criteria for something to be polar is that the molecule is not symmetrical. Okay, the molecule has a pyramidal shape. That is not a symmetrical shape. So I'm going to say the molecule is not symmetrical. So there's no symmetry there. The bonds are the same, yes, but it's not a symmetrical shape. So I'm going to say molecule is not symmetrical, and then you have to add, so dipoles do not cancel out. Okay, so you're telling me that the molecule is not symmetrical because it's a pyramidal shape. Because it's not symmetrical, those dipoles are not cancelling out. Okay, and I'm going to move on to the rest of the exam questions, which start here on page 19. So the first one, you're asked for a definition. It's for 2 marks. You need to say for the first mark, the ability of an atom to attract electrons. And in the second mark, you need to specify that it's attracting electrons in a covalent bond. Okay, so that's your definition. Just learn it off. Draw a 3D diagram. Okay, so because it's 3D, I need to show that all of the bonds are not in the same plane. So I'm going to draw my carbon. That's going to be my central atom. And I've got 2 hydrogens and 2 chlorines to draw. I'm going to draw, because it's a tetrahedral 3D structure, I'm going to draw 2 atoms, and it doesn't matter which 2 you draw. I'm going to draw 2 atoms with straight lines. That shows that they're both in the same plane as carbon. They're all on the plane of the paper. Then I'm going to draw a dash line to show that one of those chlorines is going back into the plane of the paper. And I'm going to draw a wedge to show that one of those chlorines is protruding out from the plane of the paper. Okay, it doesn't matter which way around you put these atoms, as long as you've got 2 lines on the plane of the paper, you've got 1 dash, you've got 1 wedge, you can put these anywhere. In actual fact, it doesn't have to be 2 straight lines, a dash and a wedge. It just needs to be 2 of the same lines and then 2 different ones. But this is the most common representation. Okay, so that's your 3D structure. Now you need to indicate polar bonds. Okay, so chlorine carbon bond is going to be polar. Chlorine is more electronegative, it's going to be delta negative. Carbon is going to be delta positive. This chlorine is also going to be delta negative, okay? When I look at my hydrogens, hydrogen-carbon bond is not polar, so I'm not going to be putting charges on my hydrogen. I'm just going to have my delta positive on my carbon and delta negative on both of my chlorines, okay? Explain why this molecule is polar. This is only for 1 mark. You've already shown that there's a difference in electronegativity between carbon and chlorine by assigning those partial charges. So you don't need to mention the difference in electronegativity. You just need to say that the molecule is not symmetrical. So you've got your polar bonds. Now you need to show that those molecules are not symmetrical, so your dipoles do not cancel out. Do not cancel. And the next one, you're asked which molecule is nonpolar, okay? So for something to be polar, it has to have polar bonds. All of your molecules do have polar bonds, and all of your molecules have the same bonds in the molecules. So you've got 6 SF bonds, 2 SH bonds, 3 PF bonds, and 3 NH bonds. Okay, so there's no obvious lack of symmetry. So then you need to look at the shapes and you need to see which one of these shapes is going to be non-polar. Okay, so your first shape, SF6, is going to be octahedral. H2S is going to be bent. PF3 and NH3 are both going to be pyramidal. So to be non-polar, you are looking for the shape that has symmetry because you want those dipoles to cancel out for it to be non-polar. Pyramidal and bent are not symmetrical shapes. Those dipoles are not going to cancel out. Octahedral is a symmetrical shape, which means all of those dipoles will cancel and it is going to be a non-polar molecule overall. If we look at the next question, something similar, which molecule is polar? Okay, again, I'm going to have to look and see the shapes. CH4. Okay, actually straight away, CH4, I don't have polar bonds, so I can straight away say that that's non-polar because the carbon-hydrogen bond isn't polar. C2H4, again, I don't have any polar bonds. I don't even need to worry about the shape. Carbon-hydrogen bonds are not polar, so that's going to be non-polar straight away. And then I've got CH3Cl, and I have got a CCl4. So you have got polar bonds in both of these molecules. You've got 4 bonds around carbon in both of these molecules, so they're both tetrahedral, but you've only got symmetry in one, okay? This molecule here is symmetrical because all of the bonds are the same. This molecule here is not symmetrical because the bonds are not all the same. Because this molecule is not symmetrical, the dipoles do not cancel, and it ends up being polar. So this one here, CH3Cl, this is going to be your polar molecule. The dipoles are not cancelling because the molecule is not symmetrical. Which compound has polar molecules? Okay, again, you are going to look and see. So here you have got OCl2, BCl3, CCl4, SCl6. So you've got polar bonds in each of the molecules. You're then going to need to look and see the shapes. So OCl2 is going to be the same as if oxygen were bonded to 2 hydrogens. Okay, it's going to bond to the 2 chlorines, and then it's going to be left with its lone pairs, and that's going to be non-linear or bent in shape. Okay, if it's non-linear, it's not a symmetrical shape. Those dipoles are not going to cancel out, and I know straight away that OCl2 is going to be polar. If I want to look at the rest and just make sure that they're not polar, okay, BCl3 is going to be trigonal planar. When you draw it out, trigonal planar is symmetrical. The dipoles will cancel. It's not polar. CCl4, when you draw that out, is going to be tetrahedral. All of my bonds are exactly the same. The dipoles will cancel. It's a symmetrical shape. It's not going to be polar. And then you've got SCl6. When I draw that out, it's octahedral. All of the bonds are the same. It's another symmetrical shape. The dipoles will cancel. It will be non-polar. So 4, the answer is A. Shape is non-linear. That's not a symmetrical shape. The dipoles will not cancel. And that is the end of the exam questions.